In this video, we're going to start talking about how you solve exponential equations. We've already learned how to create exponential functions, and we've spent some time learning how to graph them. And now we're going to learn how to solve them. So we're going to learn one technique today, and there's going to be a few others we're going to learn as well. An exponential equation is an equation containing one or more expressions that has a variable as an exponent. So the easiest way you're going to discern whether or not you have an exponential equation on your hands is if there is a variable as an exponent. So let's take a look at number one. There's a variable as an exponent that makes this exponential. Now, we don't have any operations right now to get this x down from the exponent. Eventually, we're going to learn an operation that does that. But for now, we're going to have to find another technique. Now, the technique we're going to rely on here, and if you can solve an exponential equation this way, you're going to want to, is to try to get both the bases the same. Because if the bases are the same, the only way these could be truly equal is if their exponents are equal. So because the bases are both 5 here, I can just set their exponents equal to each other and solve. Now this one actually solved itself. X has to be 3 in order for this to be true. As we go to number 2, you want to check out and see that once again the bases are the same. So the only way that these could come out to be equal, since their bases are the same, is if their exponents are equal. So I'm going to take 2x minus 1 and set it equal to 5x minus 2. Now if this is true, both sides of the equations will be equal. So now I go from an exponential equation to a simple linear equation. So I'll subtract 2x from both sides. I'll add 2 to both sides, divide by 3, and I get x equals 1/3. Now let's take a look at number 3. On this particular one, the bases are not the same. So I can't just set the exponents equal to each other. But if there's a way to make the bases the same, then I'm going to be in good shape. Now I can rewrite 9 as 3 squared. So I have 3 to the 4x plus 1 equals 3 squared to the x. And when I have a power to a power, I will multiply the exponents. So 2 times x is just going to be 2x. Now remember, if there's a binomial in the exponent, you're going to have to distribute the 2 through it. Here there wasn't. Now that the bases are the same, both 3 now, I can just set their exponents equal to each other and solve. So basically you're going from a more complicated situation and you're trying to make it simpler for yourself and easier to solve. So in this case, I'll subtract 4x from both sides. That'll give me 1 equals negative 2x. Divide by negative 2, and I get x equals negative 1/2. So now you want to pause the video, and you want to try this technique on number 4. Okay, let's see how you did. So this time the bases aren't the same. Now, there's no way to write 8 with a base of 4. And there's no way to write 4 at the base of 8, but I can write both of these with a base of 2. 8 is 2 to the 3rd. 4 is 2 to the 2nd. And then I can distribute those exponents to the other exponent, because power to a power you multiply. And if I do that, I get 2 to the 3x minus 5 equals 2 to the 2x plus 2. Now that the bases are the same, I can set the exponents equal to each other. So 3x minus 5 equals 2x plus 2. Subtract 2x from both sides. Let's try again. So I'm going to subtract 2 from both sides. Well, let's add 5 to both sides. Let's bring the negative 5 over. And I'm going to subtract 2x from both sides, and I get x equals 7. Now for number 5, it doesn't look like we're going to be able to rewrite these with the same base. They're not the same base now. But I can write 16 and 1/8 with a base of 2. 16 is the same as 2 to the 4th power to the 2x. Now 8 is 2 to the third, but because it's 1/8, it's the reciprocal, it's actually 2 to the negative third. So now I can multiply power to a power. I get 2 to the 8x. And I get 2 to the negative 9x minus 12. Don't forget to spread that negativity. And now that they have the same base, I can just set these exponents equal to each other. I'll add 9x to both sides and get 17x. Divide by 17, you get x equals negative 12 over 17. So you're going to try number 6. Now remember, when you have a radical, you can rewrite that as a rational exponent. So I'll get you started if you need a hint here. Otherwise, pause the video now and try on your own. Here comes the hint. Cube root is really an exponent of 1/3. And the square root is really an exponent of 1/2. All right, so pause the video from here and see if you can finish. So you should distribute the 1/3 up here, and you would have gotten 1/3 x plus 1. Distribute here, you get 1/2 x. Now I don't like these fractions here, so I'm going to make my life easy. The LCD here is 6 between 2 and 3, so I'm going to multiply everything by 6. 6 times 1/3 is 2x. 1 times 6 is 6. 1/2 times 6 is 3x. And now I'm going to subtract 2x from both sides. And I get x equals 6. So this last problem, you want to pause the video, give it a try, and bring your answer to class tomorrow.